Welcome back to Advanced Maths. Today we will be looking at 2.5, which is just going to be practice questions of topic 2, which is slightly more advanced differentiation. So, I just do want to clarify that the problems we're doing, I've never done before, so I'm discovering them at the same time as you are. And the most important thing about these problem videos, question videos, and in fact any videos, is that you are trying the questions yourself. You need to try your absolute hardest before before looking at the solution that I give. So just press pause. Please do have pen and paper ready. If you don't, go right now, get pen and paper ready so you can attempt all the questions. All the questions we're doing in this video are well within your reach if you've been following along the last few videos and maybe even doing some practice yourself at home. So let's get straight into it. Sorry. So, let's say that we're given that x over y plus ln of y is equal to 5, and we're asked to find dy over dx. So, have a shot at that. Alright, so I'll assume you've had a shot. I'll come and get you if you've not tried. So yeah. Let's start by, of course, differentiating both sides with respect to x. So the simple side is this is just going to be equal to 0. ln of y, that's just 1 over y dy over dx. In fact, we obtained this result a couple of videos back, but you should be able to find this on your own very easily. Now, x over y is slightly more tricky, but even then it's quite easy. So using the quotient rule, we're going to say u equals x, v equals y, so u prime is equal to 1, and v prime is equal to just dy over dx. So by quotient rule, u prime v minus u v prime over v squared is what the derivative of this is equal to, which is equal to, so u prime v is y minus u v prime is x dy over dx divided by v squared equal to y squared. So we get this is equal to y minus x dy over dx divided by y squared, and then it's a plus here. So now we're going to try and get these over a common denominator. So we can multiply this. This is just equal to y over y squared. And so adding this together, this is equal to y minus x dy over dx plus y dy over dx divided by y squared. That's all equal to 0. And so we can do this as multiplying, so this just multiplying by y squared, that doesn't change anything, so this is equal to y minus x dy over dx plus y dy over dx is equal to 0. So now we're going to actually add this to this side, so we get y is equal to x dy over dx minus y dy over dx. We're just, instead of taking this away just so we keep signs nice, which means that y is equal to x minus y dy over dx, and so dy over dx is equal to y over x minus y. Alright, and that's our answer. It's as simple as that. Now in fact I'm going to go over a slightly trickier, or not even trickier, in fact a slightly different problem, still implicit differentiation, which will require us to do something else, but it's arguably simpler, the differentiation part at least. So we're going to find the equation of the tangent to the curve xy cubed minus 2x squared y squared plus x to the fourth equals 1 at the point 2 minus 1, right? So we're being asked to find, in fact, no, it's a point 1, 2. Sorry, I just mixed up two questions. At the point, I'm going to rewrite that. At the point 1, 2. So we need to find the equation of the tangent at that point. Now, you can go and try yourself straight away. Otherwise, what I would say is think about what you need to find the equation of a tangent to a curve. Alright, so I'll assume you've had a go. And first of all, what you need to find the equation of a tangent to a curve, or the equation of a line in general, is you need 1 point, so here we have our point, 1, 2, and the gradient of the line. But here's a gradient we're going to find by differentiating and getting dy over dx. And the method of differentiation is going to be implicit differentiation. So, sorry, I'm yawning. So what we're going to do, if we look in the bigger picture, so we're going to be differentiating this, getting some result dy over dx equals to something, then substituting these numbers into our equation we get for dy over dx, which will give us a slope. Then we can just use equation of a straight line to find what the equation for the straight line is. So let's just differentiate. So differentiating by both sides, so xy cubed, that's product rule, so let's say u equals x, v equals y cubed, u prime is equal to 1, v prime is equal to 3y squared dy over dx. You can figure this out yourself if you want, just think of it as a chain rule, but you should have had enough practice with it by now. And the derivative of this is equal to uv prime plus u prime v, well, it doesn't matter, uv prime plus u prime v, which is equal to, I'm still going to swap them around just for like clarity's sake, which is equal to u prime v is y cubed, plus uv prime is 3xy squared dy over dx, so this is equal to y cubed plus 3xy squared dy over dx. There's a derivative of 2x squared y squared, so the 2 is just a coefficient, but we can still put it in the u. Let's say that's 2x squared, v is equal to y squared, so u prime is equal to 4x, and v prime is equal to 2y dy over dx, which means by the product rule, which I'm not going to write out again, that's equal to u prime v, 4xy squared, plus uv prime, which is 4x squared y dy over dx, so this whole business is equal to minus 4xy squared. Now this is minus a positive, so it's minus 4x squared y dy over dx. And then derivative of x to the fourth is simply 4x to the third, and that's all equal to 0, because derivative of 1 is 0, of course. So now we're going to take all the dy over dx's and isolate them on one side. So 3xy squared dy over dx minus 4x squared y dy over dx is equal to, so that's 4xy squared minus y cubed minus 4x cubed. I'm just going to make sure we don't mix these up here. And now we factorize out the dy over dx, and by dividing by what we factorize by, I'm not going to write a whole other line because I'm running out of space, but we get pretty easily 4xy squared minus y cubed minus 4x cubed divided by 3xy squared, minus 4x squared y. So there we go. Now we've got our sort of formula for dy over dx, which is the gradient. And so we can find the gradient we want by finding the gradient at the point 1, 2. So x equals 1, y equals 2, which is 4 times 1 times 2 squared minus 2 cubed minus 4 times 1 cubed divided by 3 times 1 times 2 squared minus 4 times 1 times 2, 1 squared, same thing, which is equal to, that's for 16 minus 8 minus 4 divided by 12 minus 8, which is equal to, that's minus 12, that's equal to 4 over 4, which is, whoa, equal to 1. That's quite a nice result. But we're not quite done. We need to find the equation of the line, not just the gradient of the line. So we're finding the equation of the tangent, remember, not just any old line. Otherwise this wouldn't necessarily work. So y minus b is equal to mx minus a, where b and a are our points and m is a slope. So y minus 2 is equal to 1, so I'll just leave that out, x minus 1, so y is equal to x plus 1. Pretty simple equation for a pretty complex differentiation, but there we go. Now, next we're going to look at the topic of logarithmic differentiation, which you should obviously be professional at, same as all the other topics. Let's say we're given y equals x to the power of sine of 2x, and we're asked to find dy over dx in terms of x. So press pause, have a go, and press play when you're ready. Right, so let's move tried. Step 1, of course, is to take the natural logarithm of both sides, so ln y is equal to ln x to the power of sine 2x, which means that ln y is equal to sine 2x times ln of x. I like to put brackets around my signs and stuff, otherwise I find it not very clear what's inside the sign and what's not inside the sign. So now we're differentiating both sides. So the derivative ln of y is 1 over y dy over dx. And then sine 2x ln of x. Well, that's product rule. Let's see, u is sine of 2x. V is ln of x. Now u prime is technically a chain rule, but I'm sure you'll understand by now that that's just 2 cos of 2x, but you can go through the whole chain rule procedure if you want. And v prime is just equal to 1 over x. And so u prime v plus uv prime is equal to u prime v is 2 cosine 2x ln of x plus uv prime, which is sine 2x over x. So that's equal to 2 cos of 2x times ln of x plus, running out of space every time, plus sine 2x over x. Now we multiply this all by beautiful little y, so we get the dy over dx is equal to y times all this. I hope I don't run out of space this time. 2x ln of x plus sine 2x divided by x, but y is actually just equal to x to the power of sine 2x, then multiplied by all this, 2 cosine 2x ln of x plus sine 2x divided by x. Now this could maybe be simplified more, but time-wise, we're already 12 minutes 38 into the video, and we've not even have the questions, so I'm gonna keep going a little bit faster now. So now related rates. Let's say that the side of an equilateral triangle, right? So this is equilateral. Don't know why I put 2 lines. Side of an equilateral triangle. So let's call this L, and dl over dt is equal to negative 1.5 centimeters per second. So the length of the side of all the sides thereby are decreasing at 1.5 centimeters per second. And so what is dA over dt when L is equal to 8 cm? So press pause, have a go. Alright, let's see, we've had a go. Step 1 is to write down our equation. So A, in case you don't know this result, this is just a result of A equals BC sine theta, right? Where theta is the angle between both sides. Well, for an equilateral triangle, sine, so theta is equal to 60, and B and C are equal, in this case L, so it's just equal to L squared, and sine 60 is just root 3 over 2, so L squared root 3 divided by 2, so that's a common result for equilateral triangles. And now if we differentiate both sides of this with respect to t, we get that dA over dt is equal to d over dl, I'm going to write this ever so slightly different, is root 3 over 2 L squared, times dl over dt. So dA over dt is equal to, so d over dl of this, that's meant to be, no, that is meant to be an L, too much t's and L's everywhere, L, so power rule, that's just root 3 L times dl over dt, and so with our exact values, that's equal to root 3 times 8 times minus 1.5, which I'm going to leave the square root here, So minus 1.5 times 8 is negative 12, so it's negative 12 root 3 centimeters cubed per second is our result. So it's negative because it's decreasing, right? The area is decreasing, it's not increasing. And now I believe we actually just have parametric left. We're going to go straight into the motion in a plane and how the speed works. So parametric differentiation applied to motion in a plane, which covers also the parametric differentiation before. So let's say that, which question is this? It will be 5, I assume. So 4, 5, yeah. Let's say x is equal to t cubed minus t, and y is equal to root of t cubed. Then, what is v, the speed into instantaneous speed at 1 second? So press pause, have a go. Alright, I'll assume you've tried. And so the first step is to find dx over dt and dy over dt. So dx over dt is equal to, in fact, I'm going to add in as another question to just find dy over dx, because otherwise you won't practice that. So dx over dt, 3t squared minus 1, and dy over dt, from the power rule, it's 3 over 2, so 3 over 2 root t, because it's just t to the power of 3 over 2, and you subtract 1 to the power, so you get the 1/2, which is just root t. And so let's do dy over dx first. Dy over dx is just equal to dy over dt over dx over dt. That's 3 root t divided by 2 3t squared minus 1, which is equal to 3 root t divided by 6t squared minus 2. So that's dy over dx. And now for the speed, well, v of t is equal to the square root of dx over dt squared plus dy over dt squared, which is equal to, in this example, big square root. Oh, it's going to be quite a long thing to square. 3t minus 1 squared plus 3 over 2 root t squared, which is equal to the square root of, let's see, that's 9t to the 4th minus 6t squared plus 1. And then that's just going to be something with t. So plus 9 over 4t. So there we go. That's our equation. And now we just plug in the value of v equals 1. So v of 1 is equal to square root of 9 minus 6 plus 1 plus 9 over 4, which is equal to, so we put them all over a common denominator of 4. In fact, we'll put all the constant value. That's equal to, that's 4 plus 9 root 4, so square root of all that. Now 4 is just the same as 16 over 4, so 16 over 4 plus 9 over 4 is 25 over 4. That's equal to square root of 25 over 4, which is equal to 5 over 2 meters per second. Now the speed at t equals 1. So that's happy differentiation, and you're done with the tricky differentiation. Now later in the course you might just see a couple applications of it, but nothing very tricky. I don't know, I hope you're sad that you're done differentiation. I'm sad that we're done differentiation, but next we're looking at a fun topic, partial fractions, before moving on to integration. See you in the next video.